Yeah, hi. Welcome back. Today we will look into something more exciting, maybe than just code. We will build an audio plugin in Rust, and the easiest way to do this right now is to use nih-plug by Robert VDH. It's a nice, super simple plugin framework that just wraps the VST3 and the clap API. I have to say it's built clap first, and clap is always built in because it's just a free standard. It's completely MIT licensed. You can do whatever you want with it. And VST3 you can bring in optionally. Audio unit is not possible right now to directly build it, but you can, for example, use a clap wrapper for now to test the plugin in Logic, for example, as well. Obviously, it's not like it's not industry ready. It's not as tested as something like Juice, but I think especially to create plugins and to learn to test your DSP code, to learn how to code this stuff, it's amazing, and it's so much more comfortable to develop plugins like this than using Juice. And I just hope that enough people will get into those frameworks, into this framework maybe, and help just roughing out the edges and make it so in the future more and more plugins, commercial plugins, are built in Rust. I think it saves a lot of time. So let's get started, that I can show you what I specifically like about it. If you go to the GitHub repository here, you can see that there are a good number of plugins provided as example plugins. So there's a spectral compressor with user interface and some other good examples. So you have some tools like STFT already inside and some other nice things. Then here you see some of the features of the plugins. So for example, they are stateful, and this by default, so you don't even have to add any code. When you reload the plugin, it's just, it's still, all the parameters are set to what they were left. There is some SIMD built in already for buffer and block iterators. There are quite a good amount of features actually, and you can choose between 3 UI frameworks that are already wired up and enabled, so you can choose which one you prefer. I think a lot of examples here are made with VCR. Then there's eGUI and Iced. We will look into this later as it's a whole nother chapter. Today we'll just look into how to make a plugin without UI. And it has very good support of the clap features. And if for me the best thing would just be that the industry is switching to clap, and then we don't have to care anymore about audio units and the stuff. I would enjoy that, and then we could also make more plugins in Rust and wouldn't have to care with those super old APIs from audio unit and so on. So let's see how that works. You can find in the plugins folder, you can find some demo plugins, and also here are examples, and those are super small examples. So here is basically just a gain plugin, and that is what we are starting with as well. Here you also see how you wire up eGUI, Iced and VCR, but we will just start with a pure gain plugin. I prepared the project already. What you have to do to get started is first, when you create your library, you only have this. Then you have to add this here that just says a C dynamic library, basically a .so on most platforms, or DLL on Windows, will be exported. And this is exactly what the DAWs need. So this dynamic library is what is inside of a VST3 or a clap plugin. And that's why we have to activate this here. Then obviously we have to add nih-plug as a dependency. You can add this feature that will check that in the process function there are no allocations happening. Quite practical. You don't have to activate this. And then the only configuration, there's some boilerplate you have to add compared to other Rust programs. You have to create this workspace that just means you have another library that is another library in the same project. And here the library we are using is xtask, or it doesn't have to be a library, it's just another program, another crate inside of your workspace. And if we click on xtask, that's this folder, then you see that here we just have another package that's called xtask, and we add this nih-plug xtask as a dependency. And in the main file, there's just this little code, and all it does is really exporting the plugins. So it's using the exported SO from Rust, the dynamic library, and packaging it into the VST and into the clap format, and adding some stuff that is necessary. So this is the boilerplate that is needed. And if you like, you can also add this config.toml, cargo.cargo config.toml, and here you can just make an alias. So instead of saying cargo run package xtask release and then dash and then adding release again, it's a bit long. You can just say cargo xtask and then bundle plugin. So it's just a shortage. You can also just run this command if you don't want to add this config.toml file. And that's basically all you need to do with the setup. Remember adding this dependency, the dialab, the workspace, and then adding this boilerplate here. So nothing really complicated, just a bit of setup. And then you can go and have a lib.rs file. And that's all that is needed. So in this lib.rs file, we can create our whole plugin if we want. And this is basically now copied from this gain example. I modified it a little bit to make it a bit simpler, as I wanted to show how easy, that you really don't need a lot of code to create a plugin. And that's really nice. So let's check it out. You have the structure, and this is basically your whole plugin. This is where everything lives. You could add anything you want here, but we put the parameters of the plugin inside of this arc and create a different struct for it, just so nih-plug can add the boilerplate that is needed, that it's stateful, that it can reload it by the DAW when you load a preset again. And this arc here is just so we can clone the parameters later. Arc means atomic reference counter. It's just a smart pointer that allows to be cloned into multiple processes, so we can access the parameters later in the UI and in the audio thread. So that's the whole reason why it's here in an arc. Then there is a constructor for my plugin. That's the default constructor, and a default constructor for the parameters. Let's have a look at the parameters. Right now we just have gain. It's a float param. You will see in nih-plug there's a bunch of params. You will find int param, bool param, float param, and enum param. So it's just a nice preset for different parameter styles. So it's very easy to use. This ID is actually what is not allowed to change. You can change the name here. It doesn't matter for the DAW, but you should stick to this name because that's how the DAW actually finds and identifies your parameter. And here in the default implementation of the gain params, you just say, you just call the new function, and here you can specify the default values and give the visible name. So that's just the name that the user is seeing in the DAW, and this is the ID, not to mix them up. Then we just say our default gain should be 0, and then we have a range from -10 to 10 dB. Then you can even have a step size. There is smoothing built in. So here we want to have a linear smoothing with 50 milliseconds. So when a value is changed, it needs 50 milliseconds to go there. So there's no audio artifacts that are generated. If you don't have to add the smoothing, then you will, if you move it fast, you will hear some crackles. in the DAW. Then you can add a unit, and that's also just for the DAW, so it can show this unit in the output. Then there's this plugin trait. So you have to implement plugin for your plugin. And here's just everything inside that that has to be implemented for any type of plugin, no matter if you create a clap or if you create a VST3. Just like the name of the plugin, the vendor, some metadata, yeah. Then the audio I/O layouts, that just tells how many channels you support with your plugin. So you don't, yeah, here you see it's a list. It's a list or an array. Yeah, it's called array in Rust. And here you can just specify all the layouts after each other that you want to support. Yeah? So here we support 2 inputs, 2 outputs, but we also support 1 input and 1 output. Yeah? You can also just say delete 1, and then we only support 1 layout, so only a mono plugin. But now we support stereo and mono. So it's quite, quite nice how to add this here. I really like it. Yeah, then you can specify if you want to have MIDI input or not. We don't need it now for this easy plugin. There are even like those sysx messages. And we want to, we don't need sample accurate automation now, but here you can activate it. That's just a feature for the DAW to synchronize everything better. Here you can read what it actually means. Then there's this params function, which just returns the parameters. That's not used by us. But the interesting thing is the initialize function. This is called when the plugin loads or when the audio settings change. Could also be called in between of the DAW. You never know exactly when it is called. But this is, here you are allowed to allocate memory. Here you can set up your audio processes for the audio, for the buffer config, yeah, and the audio layout. So here we see how many channels are opened by the DAW, what is the current buffer size, and so on. Yeah, so we get some information about the current audio process that is running. And then in the process function, we get our actual audio buffer and auxiliary buffers if we configured that. And here we can do our processing. So there's a really nice iterator here, buffer.iterSamples, which gives you one channel after another. And then inside of the channel, we can just iterate over the channel and then get every sample that is inside of this audio. So it's very easy to do that. And in this case, we take our gain value here inside for each channel because we smooth it. So this is just how the smoothing works in here. That you only have to retrieve it once per channel. And you call this next function. And then, we just calculate here the new output volume. Yeah, and we just say samples times gain, sample times gain, and then it will work. The reason why this dB to gain is here is just, for simplicity, I just now stored, where is it here? Stored only linear values, so from -10 to 10. If you would add this directly to the audio buffer, it would be very loud. So we have to transfer this into an actual linear gain from 0 to whatever, from starting from 0, going to 1, and then for the plus range, it could go to 2, 5, 10, whatever, how much dB you specified as a maximum. Okay. So that's a quite easy for loop here. And then you can return the process status. So if something happens where you cannot continue processing, you could also return a different process status, like an error or a keep alive. That means this plugin will continue to produce sound regardless of whether or not the input is silent and should thus not be deactivated by the host. There are just different things you can return here. All right, then there's the reset function, which is mostly not used, but here you could clear state, like when you have filters or envelopes, you can clear that state. And the deactivate is just to clean up resources at the end of the life of the plugin. Yeah, So this is all which is specified for every plugin, and really the rest is just some boilerplate here for clap or VST3 specific stuff. So the standards just have different information they need, and the clap plugin needs a clap ID, description, and you can add some features what your plugin is supporting. So there are those clap features. And here you can see which features are available. So that's also pretty nice. I think in C++ often you have to find this out in the documentation, and then and here it's actually an enum, so you already know which features are provided. Yeah, just get through here and see what fits best for your plugin. But for testing, you don't have to care about this. Yeah, it's just if you really want to ship this plugin, it can be nice to add those features. We don't need this here. And for the VST3 plugin, it's just this class ID with exactly 16 characters that has to be specified, and then also the categories for VST3 if you want to specify them. And also here you see there's a bunch of categories that can be specified. All right, and the really last thing is just this export macro, which just generates the code that this plugin now gets exported. It's just some boilerplate code. You can also look into that. It will just create now this clap plugin with all the extern C functions. Yeah? If you don't need the VST3, you can just delete this, for example. Yeah. And that's it. Yeah, we can, let's see, we can build the plugin now with cargo, xtask, bundle, then the name of your plugin, and don't forget release if you want it to be fast. Yeah, in debug mode it will work, but probably depending on what you're doing in the process function, it won't be fast enough. So let's build it, and then in the README you will find, I just have it for Linux now here inside. You just copy. You see here the output paths of your clap and of your VST3. You just copy this to your clap folder or to your VST3 folder. Yeah, on macOS, there's also a specific VST and clap folder in the system. I think it's library, audio, plugins, something like this. And then there's clap VST and audio units or components. On Windows, there's also a specific path that you can find out online. And so you just copy this folder. Yeah, it has to be -r because it's called .clap, but it's actually just a folder containing some stuff. And we copy this into our user clap folder. And now let's open a project. So here I just added a drum loop. Let's see. Okay, here's the drum loop. And now we can see if we find our plugin. Yeah, you should check that the path is specified where you moved it to. So we just moved it to the default path, so it should be already found. Let's have a look. Plugins or locations. And here you see this is my .clap, my local clap path. So that is already specified, so we should find it. Let's have a look here. We go to plugins. I called it Stecktag now. And here's my plugin. Yeah, as the clap version. So let's open it and see if it works. Great. It's very smooth, even if we do it fast. That really works perfect. So now you can play around with that. And the great thing is in Bitwig, I love it, you can just copy the new plugin. So if we do a change, for example, we just say we always want gain to be 0.5. That would be half the loudness or -3 dB. I am always confused if it's 6 or 3 dB because it depends, but I think it's 3 in audio. Now we rebuild the plugin. And then we just copy, call this copy command. And now you see the plugin crashed, but the DAW is still alive, and that only works in Bitwig. So on other DAWs like Ableton or I think even Reaper, the whole thing crashes. That's a bit annoying, and we can just say reload plugin. And so we also know it worked. When it crashed, that's nice because we see we actually are using the new plugin now. Yeah, and then we can see now nothing changes because we hard-coded 0.5 as our gain value. Great. So you see the changes actually take effect. And there are also strategies how you can start Bitwig or other DAWs directly here from the command line. But for now, yeah, that's great. You can also debug the commands here, the output into a file. There's a strategy for that. Yeah, there are multiple options, but I just think this is the cleanest looking plugin I've ever seen. You have so much wired up. Yeah, for example, now we take the gain to -5, save it, and then reopen Bitwig. Then you see that it's still at -5. Yeah, so it's stateful already. It just works great, and already the smoothing is built in. And I just think when I first learned to create a plugin in Juice, I was way more confused to get started. Yeah, it's still here. You have to add the boilerplate, but it's really just copy and paste. Yeah, and that's it. You can play around with it and now check what you want to do with the samples. Yeah, get a filter inside or anything else. I put the code here into my repository, Rust Audio plugin. Yeah, this is just the same code if you want to get started. And I think I also, if you want to wire this up, yeah, here's a filter. For example, this is a nice filter with a low pass, high pass, bell, peak, with all the different filter types. And here you see how it works. You just say cargo add simper filter. Then you create a new filter and set whichever specs the filter should have. And then you can just call filter.process with the input output, or here just call filter.tick on each sample. You could call this here. And then you would hear that the filter works. So that's a nice thing you could try. Very easy to do. Yeah. And I think that's it. Yeah, just a short overview. Next time we can see how it actually works to add a GUI, maybe as a pre-thing. If you go here, for example, eGUI, and you look, it's still only one file. Yeah, don't bother about the main file. There's basically nothing inside. But you just implement the editor function here, and then you can just write your GUI even in the same file. And here you access the state of the editor with the parameters. And then you can just show here the gain, for example, with a slider. Yeah, so that's how easy it is. But in detail, we will look into this another time. Yeah, thank you for watching, and have a great week. Bye-bye.